Good day, everyone. For this particular video, we'll be discussing about fuels as part of our discussion on industrial chemistry and tribology. To start with petroleum. Petroleum is also referred to as crude oil, which is basically liquid at room temperature. Petroleum was created from the remains of extinct marine organisms like plants and animals, algae, and bacteria, just like coal and natural gas. But take note, however, that coal is solid at room temperature, while natural gas is obviously a gas in room temperature. These organic remains or fossils change into carbon-rich substances we rely on as raw materials for fuel and a wide range of products over millions of years of extreme heat and pressure. Since they are buried underground and underwater at the same time, they are experiencing extreme heat and pressure. So this is the chemistry of crude petroleum. Hydrocarbons is the primary components of which are 13% of the total weight is hydrogen and 85% of which is actually carbon. And these basically make up our crude oil. Again, 13% hydrogen of the total weight and 85% is carbon. The hydrocarbons can also be combined in small amounts with other elements like nitrogen, approximately 0.5%, sulfur 0.5%, oxygen 1%, and metals like iron, nickel, and copper, which is basically less than 0.1%. Now, what is a fuel? A fuel is a substance that contains carbon and hydrogen that undergoes combustion in the presence of oxygen to give large amount of energy. This is according to Singh. So we have this chemical reaction here, fuel plus oxygen, forming our carbon dioxide and water. And what we intend to produce during combustion process is the energy output of this particular fuel. Fuels make up the majority of the materials that are burned. Fuels are substances that burn to release heat and light energy. So take note, when we are dealing with flame, blue flame is usually hotter than the orange or the yellow flame. So some example of fuels are the following. We have the wood, coal, kerosene, LPG or liquefied petroleum gas, petrol, and diesel. These are the frequently used fuels in our household. In order to cook, heat, power vehicles, and create electricity, we actually use fuels. So these are some of the classification of fuels based on their source. So the first one is the natural or primary fuels. These fuels are naturally present in the environment. Next, once we process these natural or primary fuels from the environment into other fuels, we are actually producing artificial or secondary fuels. So remember, natural is from the environment, while once we process these natural or primary fuels, we will now have the synthetic, the artificial, or the secondary fuels. So now, the types of fuels based on their state at room temperature. So it could either be solid, liquid, or gas. Solid fuels are like the wood, the coal, charcoal, and many more. For liquid fuels, we have kerosene, petrol or gasoline, diesel, while gaseous fuels contains your compressed natural gas, your LPG, your biogas, and your hydrogen. Solid fuels exist in state or in solid state at room temperature. They are usually called solid fuels like the coal, the wood, the tan bark, bagasse from sugarcane, briquettes, charcoal from wood, and straw, all of which are examples of solid fuels. We also have liquid fuels, which are liquid at room temperature. For example, we have your petrol, your diesel, your furnace oil, kerosene, ethanol, and light diesel oil, or the LD. And lastly, we have the gaseous fuel, which are usually stored in a tank. Fuels that exist in gaseous state at room temperature are called your gaseous fuels. Examples would be your petroleum gas, your natural gas, biogas. Now, let's go to the characteristics of a good fuel. So take note of these seven characteristics of a good fuel or in choosing a good quality fuel. The first one, fuel should have high calorific value. What does it mean when we talk about high calorific value? Calorific value is actually the heat produced during complete combustion of 1 kilogram of fuel. So therefore, when you burn 1 kilogram of fuel, the amount of heat or energy generated is actually your calorific value. So based on this particular table, we have hydrogen as having the highest calorific value, followed by your methane. We also have the propane and your gasoline. For the lower calorific value, we also have here your wood, garbage, and your methanol. Number two, must have moderate ignition temperature. Why does we have to secure that our fuel has a moderate ignition temperature? Number one, if it is high ignition temperature, it will not easily burn or ignite during the process in our engine. And number two, once it has a lower ignition point, then therefore it will be also be very difficult to store since it is very reactive and flammable at the same time. Number three, fuel should have low moisture content. Of course, we don't like to have moisture in our fuel as much as possible since it will be associated with water. It will actually form corrosion and then if there's water in our fuel, then therefore it will also be prone to bacterial growth. So as much as possible, we need to minimize or to avoid moisture in our fuels. Number four, available in bulk at low cost. Of course, we need to have operations having low budget, no, but at the same time, quality output. So available in low cost will be our main goal for our fuel. Number five, should not burn spontaneously, meaning it must not be easily burned during the process. For example, you have your paper. Once you burn it, it will actually burn spontaneously, and after some time, you will need to change your fuel because it is not enough in the system. So it must not burn spontaneously. Number six, fuel should burn efficiently without releasing hazardous pollutants. As much as possible, we wanted to have a fuel which has lower air pollution effect. Like for example, fuels that has of lower sulfur content is a must since we will be avoiding the deposition of SOx in our atmosphere and later on combining with water and nitric acid in air, we will produce your acid rain. And last, for characteristic of a good fuel, we have handling, storage, and transportation should be easy. For safety purposes, at the same time for continuous operation, we don't like an explosion in our tanks or in our vessels. So as much as possible, handling, storage, and transportation of these fuels should be easily handled. That's it for our fuel discussion. Thank you so much and see you our next week. Bye bye.